welcome to Great Minds Tutorials. This is the second episode of Grade 12 Mathematics. And as your favorite tutor, Khwadiso, I'm back with another one. Let me just quickly test something here. I want to test if my device here is working properly. Okay, everything seems to be in order. So we're gonna work out our solutions. Okay, perfectly fine. All right. All right, then we can begin. As a reminder, we are using the Everything Mathematics by Siavola, and that is the one that we are actually using in order for us to go through this journey of grade 12 mathematics. And then, okay, in the previous part, which is part 1, I was doing arithmetic sequence, and I'm going to continue with the arithmetic sequence section. And today we're going to speak about what we call an arithmetic mean. So as you can read from this the description here, it says that the arithmetic mean between two numbers is the halfway between two numbers. And in other words, is the average of two numbers. So the arithmetic mean and the two terms form an arithmetic sequence. So what this actually means is that, let's say you are having, let me just quickly write it the side, when you want, so let's say for example, you want the mean for, you want the mean for 7. Let's say you want the mean, this is not the right thing, I don't know why. Okay, just quickly try and come this side. Okay, it's fine. It's fine now. So let's say we wanted the mean between the number 7 and, but it's an arithmetic mean. We wanted the mean between the number 7 and 17. So basically, what this simply says is that now you're going to say that in order for you to get the arithmetic mean, it's going to be, so the mean is going to be a 7 plus a 17 over 2. And in this case, what is going to happen is that you will basically then have to make your calculations. So what is 17 plus a 7? It's going to be 24. And then you'll have to divide this by 2. And then this is has to be a what you call? And this has to be a 12. So and then this should tell you that now, since you are having the mean between 17 and a 7, a 17 and a 7, so this simply has to tell you something. It needs to tell you that therefore 7, 12, and 17 are actually what you call an arithmetic sequence. So it means now this should tell you that 7, 12, and the 17, they are actually an arithmetic sequence. So, but how do you prove an arithmetic sequence? Is that you must have a common difference here. So when you check 12 minus a 7, you get a 5. And a 17 minus a 12, you get a 5. So you have just proven this. And therefore, you can say that this is actually right, that every time whenever you get an arithmetic mean, the mean is the number that is going to sit in between those two numbers, and that those three numbers should be able to give you an arithmetic sequence. So going back here to the textbook, you can actually see that that is what they worked out. They said a 7 plus a 17 divided by 2, they got a 12, and then therefore a 7, a 12, and a 17 is an arithmetic sequence. And this is them proving it, and they've proven it, and they've actually plotted it here by using the formula, which is Tn, general formula. Tn is assigned to, it's so meaning that it's equivalent to an a plus an n minus 1 multiplied by a d, whereby the d is actually the gradient. So the d is actually the difference. So now going forward, it's we could actually also do this questions. So let us try and do these questions before we can jump to the other side. So, okay. Now let me just quickly write this before I turn over to the other side. Need to underline here. Okay. So we're having the number 7, the number 5.5. We're having the number 4, and then we're having the number 2.5. So the question A says that we must find the first. Question A says that we must find the nth term of the sequence. Okay, we're gonna quickly work that out. So coming back to where I have to work out the solution. So the first question says, which is question number 1, it says that I must work out the nth term, and the nth term is Tn. That is what I'm looking for. And we know that whenever you're working with an arithmetic sequence, Tn is given to by a plus n minus 1 multiplied by d, which is the difference. So in this case, what we're going to be doing now is that we will then have to substitute each and every value that we have into there. But before we can substitute any value, we need to first make calculations of d, which is the difference. So d says you can have it as t2 minus t1, and we're going to have a 5.5 minus a 7. So we can have this as a what? As a 5.5. We can have this as a 1.5, but it needs to be a negative 1.5. It needs to be a negative 1.5. Okay, let me just make sure that everything is clear and visible. So it needs to be a negative 1.5. So let's prove it. Common difference, T3 minus T2, and then we are having a 4 minus a 5.5, which is also still equivalent to negative 1.5, which is actually true. So now we have proven that, okay, this negative 1.5 is actually the common difference. So in this case, what we're going to do is that we have already figured out what D is. Now we know what A is. A is given to as the first, A is given to as the first number. So and then we're going to say that Tn is then equivalent to A. Okay, now let us just substitute. So in this case, we're going to quickly go back up. And if you check, you'll see that A is a 7. So it means what we're going to do is that then in place of A, we're going to substitute a 7. So let's just quickly erase this. So we're going to substitute the 7 plus a bracket. Let's give it a minute. Okay, let's close this. All right, it's fine now. So we're going to have n minus 1 times negative 1 times negative 1.5. So it's a times, yeah? So it's times a negative 1.5. So, and then we're going to work this out as a 7. And then we're going to say plus. Let's start with the plus one. So we're going to plus a 1.5. We find it by saying this minus 1.5 here. This minus 1.5. This one multiplied by negative 1. And then we're going to have negative 1.5 n. And then to continue with this, then we're going to take like terms. So we're going to take the constants. And as you can see here, your constant here is L7 and 1.5. Then we're going to get an 8.5. Then we're going to minus 1.5 n. So this should be your general arithmetic sequence. So the general term. So that should be your Tn based on this one. So, but now the question A says you must find the next term of the sequence. So as you check here, this is term number 1, and then this is term number 2, and then this term number 3, and that is term number 4. So now in this case, we need to go in, and then we need to say that, okay, now what do we have here is that we need to then say, okay, now we need looking for term number 5 with T5. So it means in place of n, we need to substitute the 5. So this is going to be 8.5 minus 1.5 times a what? Times a 5. So we can have a calculator here. Let's open a calculator so that we can confirm our answers. Okay. So it's 8.5 minus 1.5 times a 5. That is going to give us a 1. That is going to give us a 1. So from that, we can get that, okay, since we are getting a 1, we need to be able to prove this. And us trying to prove this, it's going to be us saying that now a 1, which is going to be T5 minus T4, is equivalent to 2.5 minus a 1. No. Sorry about that. So T5 is a 1. I've mixed them up. So we're going to have a 1 minus a 2.5. And we're going to get a negative 1.5. And if you can compare with up there, you would realize that it's actually consistent with that. And you will realize that it's actually consistent with that. And you can realize that now that is proven. And we can then conclude that the next term is 1. And that is the conclusion. Then we can underline that we are done. So in that first segment of this question, which is saying A, we need to determine the next term in the sequence. So the part B says that we must determine the general term, and that one we are already done with it. So for the B part, the general term is Tn is assigned to, let's just quickly confirm it. We're having it up here. So the general term is 8.5 minus 1.5n. So that is the general term. That's Tn. So we're having it as, let me just quickly try and increase this. We're having it as 8.5 minus 1.5 n. That is the general term. So that is to answer part B. So and then for part C, which is this one, then what we're going to do here, it says that you must find which term has the value negative 23. Okay. So to answer part C, I'm going to come this side. So negative 23, it's what we're looking for. So it means that Tn is equals to what we are looking for, negative 23. This is what we are trying to figure out. We're trying to find, but n is what we are looking for. Someone to put a question mark for n. So in this case, what we're going to do is that when we are looking for n, then we're going to say that then Tn is assigned to negative 8.5, sorry to say, minus 1.5 n, and we are going to assign this to negative 23. And then what we're going to do is that we're going to take the 8.5 to the other side. Then we're going to be left with negative 1.5 this side, and then is equivalent to 23, negative 23, minus. So that is what we were looking for. Let's confirm negative 23 minus 8.5. Why? Because when you take the 8 to the other side, let's just write this properly. That is an 8.5. Because when you take this to the other side, it's going to change signs. Then it's going to become a negative. It's going to change from an 8.5 to a negative. So and then what we need to do, we need to go back to our calculator. Let's just quickly go back to confirm. I think I've closed it here. Let's open it again. Okay. I think I should have a calculator in hand so that it's going to be a little bit quicker. So we're saying negative 23. Negative. It's not responding. Let me just quickly get my calculator. So now, negative 23 minus, just quickly doing the calculations, 8.5, we get a negative 31.5. So yeah, we're going to get that, negative 1.5 n is equivalent to negative 31.5. So scroll this up. Okay. So and then to solve and make n the subject of the formula, then we're going to have that n is equivalent to negative 31.5 divided by negative 1.5. Then we'll need to solve for n. And in order for us to solve for n, we'll say n is equivalent to, we'll say negative 31.5 divided by negative 1.5. Then we're going to get the number, which is 21. So then means therefore, therefore we can conclude that therefore, 3 dots, the number negative 23 is the 21st term. So we've concluded that the number negative 23 is the 21st term, but we need to be able to prove that. So how can you prove that? You can prove that by then, this is just extra stuff. You can prove it by saying T21, and then you substitute back into the general formula and see if you're going to be able to get the negative 23. So into the general formula, we're going to have it as a 8. Let's just check the general formula up there. 8.5. Okay. So that is a 8.5. 8.5 minus then now we're putting in 21 times 1.5 because it's n. So we want to prove this. We're going to say 8.5 minus 21 times 1.5. And we're going to be able to get a negative 23. So that should be proven. So that way, we have proven that the number negative 23 is actually going to be the 21st term. So we're going to highlight this. So now we are having the second one. And let me just quickly write it on this side. And what we're going to be having here, let me underline first. Underline here. And then let me highlight here so that I know where I'm starting. Underline, highlight. Okay, then we can, let me just quickly write the numbers, which I'm going to need. So I'm going to need the number, which is a 2. The number 2. I'm going to need the number 6. I'm going to need the number 10. And I'm going to need the number 14. So, okay, as we go back to the question, the question says that we must find A, is this an arithmetic sequence and justified by calculations? Okay, so coming this side to solve A, we'll say A. So how can we prove that this is an arithmetic sequence? We can prove that by getting a common difference. So we can try and calculate the difference. So now we can say T2 minus T1 is equivalent to 6 minus a 2, we're going to get a 4. And then T3, I mean to say T3 minus T2 is equivalent to 10 minus 6, which is equivalent to a 4. And we need to do it for all of them. And the last one that we can do is that T4, I mean, minus T3 is equivalent to 14 minus a 10, and it's also equivalent to 4. So let me just zoom out a little bit here. So this is visible. So then now, what we're saying that since T1 minus T2 is equivalent to T3 minus T2, T2 minus T1, yeah, it's a 1, yeah. Let me just erase this. It's a 1, yeah. And it's also equivalent to the last one, which is T4 minus T3. Since T1, T2 minus T3 has a common difference for, since we're saying that it's got a common difference, which is a 4, we can then conclude that we can then conclude that sequence, which is 2, 6, 10, 2, 6, 10, and 14, is an arithmetic sequence. Guys, my handwriting is very bad. I've just realized today that my handwriting is very, very bad. Okay. So, but at least I'm narrating everything that I'm writing. You will realize that actually what was I trying to say. So far, we have got to that level. We have started up here as we're moving through. Okay, so we are getting somewhere. So that is the A part of that question, which is this one. That is the A part. So now we're going to look to solve the B part. Let's just go back this side. So what does the B part say? So the B part says, okay, let's underline this. Highlight it as green. So the B part says that we must get T55. So we're looking for T55. But before we can calculate T55, we do not know what is Tn. So we need to quickly get Tn. So and then we're going to see that Tn is assigned to the first is 2 plus an n minus 1, and the difference is a 4. So to solve this, what we'll get is that, so in order for us to solve this, okay, let's just erase this. We need to erase this. And then in order for us to solve this, we're going to say this is a 2 plus a 4n minus a 4. And we're going to get that this is a 4n minus a 2. So that is Tn. So after we have found the Tn, then we are going to look for T55. So T55, it means that in the place of n, we're going to put a 55 plus 55 minus a 1 times a 4. Then we should be able to solve this as this is going to be equivalent to a 2 plus a 54 multiplied by a 4. I'm going to do each and every step. So this is going to be a 2 plus, so it's going to be times 2 is going to be 108. So 108 plus 108 is 216. If I'm not mistaken, let me just confirm. 54 times 4 is equals to 216. So we're going to find that now T55 is actually 218. So that should be your final answer, 218. So the final answer should be a 218. That should be the answer for T55. So, all right, that should be fine. And the other way that you could have done this is that you could have first calculated. Oh, I'm the one who has done it the other way. I've just simply substituted into the A. This is A. I'm the one who's a little bit forward. This is a A, that's a N, and that's a D. So, but you could have easily took the Tn, which is up there, and you will have substituted by saying that now Let me just quickly close this. You could have substituted it simply by saying that T55 is equivalent to 4 times 55 minus a what? Um, uh, 450, it's 4 minus 2. I mean, it's 4 times 55 minus a 2. So 4 multiplied by 55 and then minus a 2, you are actually getting 418. So this is 420 minus a 2, and you're going to get 418. So you're going to get the answer, which is 418 here. So that becomes actually much easier that way. In order for you to actually do it using that TN. So I was a little bit forward whenever I use the actual thingy, the general formula without actually using the TN that I've calculated there. So, okay. So for that question, let me underline here. Let me highlight that this is where this question ends. And I'm going to continue. So, okay, look at the C part. So we're done with this B part. So the C part, it says which term has the value 322. So for the C part, it should be straightforward. We are having Tn. We're having Tn. It's 4n minus 2. And then we are having the Tn is equivalent to 322. So we go back this side. We are having it like that. So now we're looking for n. So n, it's what we must question. It's what we are looking for. So now in order for us to calculate n, what we need to do then is we need to then say now 230. Let me just quickly go 322. Let me just zoom out a little bit. Come here, remove this. So 322. Sorry about that. 322 is equivalent to 4n minus 2. So when we take 2 to the other side, we're going to get that 4n, it's equivalent to 324, because it's going to become a positive. So and then in order for us to solve this, to make n, okay, let me just quickly remove this, remove that, remove this. Okay, zoom in here. Okay, so we're going to find that, let me continue on the side. We're going to find that n is equivalent to 324 divided by 4. So therefore, n is equivalent to 324 divided by 4, and we're going to get an 81. So and then we can conclude here by saying that therefore 322 is the 81st term. That can conclude your solution. The 322 is 22 here. 322 is the 81st term. So that can be able to conclude your solution for number C. And now, yeah, this question says that determine by calculations whether or not 1,204 is it wants to determine whether 1,204 is a term in the sequence. So that should be straightforward also. What we need to do is that, let me just quickly write the answer, the number this side is 1,204. Then let's quickly go that side. Okay, so that is the number that we want to check if it's within the sequence. So and then it means that number must then become our what? That number must then become our Tn. So let me do this. So it means this number must then become our Tn. So and then when we are having Tn is equivalent to 4n minus 2 as our general term, minus 2. So here we're going to put 1,204, and here we're going to have 4n minus a 2. So and then we're going to have, taking that to the other, making n a subject of the formula, we're going to have a 4n, and then we're going to have 1,206. So and then to continue on this, we're going to say the n is equivalent to 1,206 divided by 4. So therefore n should be a whole number in order for it to be part of the sequence. So if this is not a whole number, then that should conclude that it's not part of the sequence. So we say 1,206 divided by 4, which is going to give us 301.5. So this is going to give us a 301.5. And we're going to conclude, so since this is a decimal and not an actual whole number, then we're going to say, therefore, 1,204 is not part of the sequence. It's not part of the sequence. So that is what we can conclude. Why? Because here we are getting a decimal number. Only if we're getting a whole number, then we can say it's part of it. Because the whole number is a counting number. So n must always be part of a counting numbers, your whole numbers. It can never be a decimal number. So that is how we can conclude that question, this one. So now I'm gonna leave you guys to do question number 3 to question number 8, or we can continue with them on another episode. Why? Because we want to go through each and every information properly. And in this tutorial, or on this channel, we're going to be looking at mostly the questions, because math is all about practicing, and practicing the questions makes you to be able to master the subject. And that is it from me for today. Till the next time we drop, please remember to like, share, comment, and subscribe. From your favorite tutor, Khodiso, that is it. I'm signing out. Cheers.